Hey everybody, this is Mr. Munson. We are in Unit G.2, Logic and Reasoning. This concept is number 3, G.2.3, Conditional Statements. Este video está dedicado a Catherine, en mi primer periodo. Sus comidas favoritas son las enchiladas. ¿Verdad que se ven deliciosas? Eso no tiene nada que ver con este unit. Puedes sentirte libre y ponerla en pausa y mirar a estas deliciosas enchiladas. Cuando estés listo, pon play. Okay, let's get started.
All right, let's change this from 9.3 to G.2.3. All right, very good. So this section is about deductive reasoning, Venn diagrams, and compound statements. So let's start with this idea of deductive reasoning. Now we've talked about inductive reasoning. Inductive reasoning is when you see a pattern and you're making your best guess to what that next step is. Deductive reasoning follows, in this case, in this class, two laws. One's going to be called the law of syllogism, and the other one is called the law of detachment. And so the law of syllogism is used when you have a series of conditional statements. And it's really important you take a look at the conditional statements and you notice that the conclusion of this one matches the conclusion or the hypothesis of the next one. And then you look at the next one and the conclusion of the second one matches the hypothesis of the third one. And so this string of conditional statements can go 5, 6, 7 deep. It doesn't matter. It could be only 2 of them. It doesn't matter. As long as it lines up, it's great. If for some reason you have to move the statements around to get them to hook together this way, then that's what you do. Okay? So I just happen to notice that this series of conditional statements line up. If this is the case, as I said, the conclusion matches the hypothesis, and it's like a train. I see a train kind of hooking up this way. Then I can use this thing called the law of syllogism. It basically says this: if P happens, then Q happens. Hey, if Q happens, then K happens. And if K happens, then L happens. And the law of syllogism gives me the power to write, if all that is true, then I can conclude if P happens, then L will happen. If the first thing happens, then the last thing happens. That's a logical conclusion. Now, I'm going to look at an example of this, and I'm just going to use 2 conditional statements. Now, again, the example I just showed you over to the left has 3. I'm going to use the law of syllogism on this, and what I notice is if you work hard at the gym, then you sweat. Now, that's the conclusion of the first sentence. If you sweat, hey, that matches the hypothesis of the other one. If for some reason I walked into this problem and these things were reversed, then I would rearrange them to get it so that they're in the correct order. And then I could come to a conclusion. Now, these 3 little balls represent the word therefore, or my conclusion. Okay. Now, I'm already using the word conclusion when I'm talking about a conditional statement. I have hypothesis and conclusion. And so I'd just like to say, as we talk about this, this really just will be the word therefore, what I finally conclude. Since this stuff matches up, then I can take the first thing, if you work hard at the gym, and combine it with the last thing, then your clothes get wet, as a logical sequence. Okay, so again, this is our conclusions. Now, when we are using the law of syllogism, the conclusion is another conditional statement. That's important. The law of detachment, the result is the therefore will just give you a simple statement. You'll see that in just a second. So you can kind of see from the result in my problems here if I'm using the law of syllogism or not. This is a law of syllogism problem. I have a series of conditional statements. nothing's happened, I can just combine and work the two together to simplify it and say, if you work hard at the gym, then your clothes will get wet. That's a natural conclusion to that series of conditional statements. Now, again, I want to encourage you that if at this point you're not sure what all that was just said and what that meant, then you would put it on pause and back up and just make sure that you understand the law of syllogism. It's a tool to allow you to take a series of conditional statements that have a special order to them and then come to a final conclusion that's much simpler. All right, so let's just review real quick. I want you to put me on pause and see if you can write the inverse, converse, and the contrapositive of that conditional statement. Try to do this without peeking, but if you can't, you have two choices. One, go back and look at your notes, or pull out a computer, a smart device, or whatever, and do some search on Google and find this out. Put me on pause and come back and check your answers. All right, so hopefully you got those correct. Remember, for me, I just try to remember the converse is the one that moves the pieces, and converse shoes is a way of moving my body. Once I remember that, then I just know that the inverse is the one that negates both of them, keeping the same order. And the contrapositive, which by word is much harder to say than any of the other ones, and it is the most work. It moves the two, and it takes the inverse of both statements. All right, let's take a look at the right-hand side. I want you to go ahead and put me on pause and see if you can write the conclusion of this using the law of syllogism. Okay, so I hope that you wrote that and got that correct. It's pretty easy. And again, if you didn't get it correct, you need to go back and look at why that would be the conclusion. Okay, now we're going to look at the law of detachment. And so now that we're adding in something that kind of sounds similar together, it might get a little bit confusing. So you're taking good notes. When you get to your do it problems at the end, you've taken some good notes. You get to look back and see what it is that you did and make sure you get it right. Okay, and I've said this before in class, don't practice wrong. When you practice wrong, you teach your brain wrong. And so when you go to show me mastery, it's wrong. And so you don't get those points. And that's a silly way to play the game. Okay? Play the game the best way. Do it right, slow down, and check your work. Use your notes to help make sure you're not guessing at how to do problems the first time. Then when we're practicing in class, then you can kind of speed it up because you've gotten a little bit more used to it. Okay, so this is called the law of detachment. And I could have a conditional statement, P then Q. That's true, right? If P happens, then Q happens. Then I tell you P happens. Now keep in mind these letters represent words. They're statements. They're just simplified, like if I'm in Paris, then I run quickly or something like that. So P would represent, hey, I'm in Paris. So what would be the natural conclusion? Well, that I run quickly, right? So Q happens. So notice that it's not a result. The therefore is not a conditional statement like a law of detachment. It is that something else happened. Okay, so this right here, when I write that, it's written or it's read as P happens, right? Of course, this one right here is if P happens, then Q happens, right? We just drop off the if. Bye-bye. Sorry for the background noise there. Custodian doing a great job. P then Q. P happens. My conclusion is then Q must have happened. Okay? All right. So let's see if we can apply this. I have some statements over here. If I eat shrimp, then I break out in hives. Oops, I just ate shrimp. So that is a way of saying, hey, you know what? The first thing just happened. I accidentally ate shrimp. So then what is the natural conclusion? Yikes, I'm going to break out in hives. The second thing's going to happen. Again, notice that the result is not a conditional statement. The law of detachment happens when something else happens, right? So we get to use the law of detachment to come to a conclusion that's not a conditional statement, but that something else has happened. Now let's take a look at this problem. It's a little bit more complicated. I walk up to the problem, and first of all, it's telling me something happened. So I know that the law of detachment is going to be something I can apply here. So first of all, I'm going to see, I have a law of series of things. I'm going to see if they line up. So the first and or the second and the first line up in that one. But take a look at the next set. There's no Q here. So let's talk about this one. I mentioned this in class, and that is whenever you have a statement like, let's say, P then Q, okay, its contrapositive is equivalent to it. If P then Q is true, then not Q, then not P is true as well. The same thing as being false. Now make this note. If you know this one, then you know this one. And these can replace each other. And that's what's needed here. I need to take this Q then not Q, and let's write its contrapositive and see if that will be helpful. And there it is. So I switched their places and then negated it. So now I'm allowed to take this one and bring it and put it in place. And take a look. It lined up now. So the law of syllogism says that I can now come to a conclusion that K then T must happen. Now I really don't need to know that. When I'm told that K happens, then I know K happened. And if K happened, then L happened. And if L happened, Q happened. And if Q happened, then not R happened. And if not R happened, guess what? T must have happened. And that's my conclusion. Now let's look at compound statements. This is a compound statement here with an and symbol in between it. Okay? But I'm going to use Venn diagrams in this to help us with it. Now, we know that in the middle of a rhombus and a rectangle, these are two different kinds of shapes, that a square is a rhombus and a rectangle by definition. So this is both a rhombus and a rectangle. Okay? So a square is the same as a rhombus and a rectangle. Okay? Now take a look. I have two of these. I have a bunch of shapes. Two of them are rectangle and rhombuses. Six of them are rhombuses, not only, but they are rhombuses, and then five are rectangles. So what I'm going to do is I'm going to put this information into the diagram. Okay? Now, pay attention closely. I'm going to take the and part, the ones that go there, and I'm going to put them in the spot there first. Let's use a different color. We'll use green. So there are two that fit there. Whenever I'm doing these kind of problems, I always put the middle ones, the ones that go in the middle here, the ones that have both characteristics, I put them in first. Then I do the other ones. Now, according to this information, I have 5 rectangles. Now, careful, I'm not going to put 5 dots over here in the rectangles. That would indicate that I have 5 rectangles and none of them are rhombuses. So don't do that. I have 2 rectangles that are already accounted for there. So what I would do is put 3 more that are just rectangles. Now the combination of these 3 plus these 2 give me 5 rectangles. All right, now let's do the rhombuses. 6 rhombuses, so I have 2 of them already accounted for in this middle area. So 2, 3, 4, 5, and 6. And so total, I have 4, 5, and 6 rhombuses because they fall all in the circle for a rhombus. This is possible by first doing the intersection first, the ones that are both the same. Let's take a look at this one. I have 3 people that swim, 4 people that jog, Now, I'm not saying that that's all they do. They might jog. I just know that there's 3 people that say that they swim. There's 4 people that jog, and I have 6 total people. So if I was to set this up, let's put 3 people over here for swimming, okay, and 4 people over here for jogging. That would give me a total of 7 people. So I have to come up with some kind of arrangement. Obviously, there must be some people who swim and jog. So think through how many people fit in this middle category that swim and jog that will allow me to have 6 people. Put me on pause and see if you can come up with that answer. Really think through this. This is that part of the brain that we're trying to exercise. It's like a game. I see that if I can just move one person, if I can move one person in here, I still have 7 people. What that implies is that one of these people is both a swimmer and a jogger. So if I put one person in there, you'll see that I have 1, 2, 3 people as swimmers, and then I have 1, 2, 3, 4 people as joggers. I hope that makes sense. If not, go back and look at that. All right, so here's your do it problems. I'm going to zoom in and scroll through them. I might add some information to each one of those to kind of help jar your ideas. All right, take a look. On the first one, I have something happens, and on the second one, I just have a series of conditional statements. So one is the law of detachment, and one is the law of syllogism. Go back and review that if you're not sure how to use it. All right, so which law am I using here? So I have a conclusion already written in. I have a series of conditional statements, and then I have a conclusion. So which one is law of detachment, and which one's law of syllogism? All right, so here's an example of a problem like that I just did. Now, if you look at the 3 students, this S and J, that should be the first 3 you stick in, and they all just go in the middle. 3 go in the middle. Now you need to get the other 4 and 5 to work so that you end up with only 4 swimmers and 5 or 4 joggers and 5 swimmers, but some of them are already accounted for here in the middle. In 5, you're using the vertical angles and the triangle sum theorem. If you're not sure what these things mean, you just simply look them up on Google, and that will help you walk through those kind of problems. And then the last one, you're going to take that one and use the triangle sum theorem. And again, if you're not sure what that means, just do Google, and that'll help you with it. Okay? All right, that's it. Sorry for running a little long. Hope you have a great day.